So 3.1 all the way to 3.6, we're going to be graphing. Here we go. Just real quick here, some few things you probably should remember, if not remembered here. Remember the X and Y grid? We have the X-axis coming across, we got the Y-axis coming down. And then we have these, it's called quadrants, where you really don't need to know these here up until you get to trigonometry. But we have quadrant 1, quadrant 2, and then quadrant 3, quadrant 4. They are always in Roman numerals. And then the dead center crosshairs here, that's called the origin. I think we're good there. Real quick, you ready? Not going to be tested on that, okay? But let's go for it. Just real quick, a review of order pairs. Sophisticated Math 63 students probably don't need a review, but just in case. Can you guys graph those? Put a little dot. I'll do the first one here, and then label them, because it doesn't make sense if you just put dots everywhere and you don't know which one's which. So like this here, 1, 3 would be in quadrant 1, and right next to the dot, put down the coordinates that you have just graphed. All right, -1, +3 would go in quadrant 2, right over here. Then we have -1, -3. And then last one here in quadrant 4, how about +1, -3? Whenever you're graphing individual points, we always start off with the origin, right? The first number tells us if we go right or left, depending on the sign, and then the second number tells us to go up or down depending on the sign, which I think you guys already knew that. Okay. Alright, so if you guys are that sophisticated, give you some more, of course, with zeros and fractions now and all that good stuff here. So all yours. Okay, I'm going to check your work here. Or maybe you guys check my work just to make sure. 4, -2 is down there. Quadrant 4. -1/2, +3. So we're going to go a half from 0. Literally here. And then we're going to go up 3. So should have been about right there. 1, 0. That's an easy one. 0, -5 should have been down here. -6, 0, all the way to the left of the chart, and how about 0, 4, kind of a little bit above the -1/2, comma 3. Quick here, show of hands, how many got all of them correct? None correct? Cool, cool. Hopefully it stays that way throughout the rest of the section here. What's some few things here? Notice we would actually say that 4, -2 is inside quadrant 4. We good? But whenever they are on the axes right here, they're not really in any quadrant whatsoever, because you have to be sort of above the axes on each of the sides, or to the left or the right. So like on 1, 0, that you would not say, you would actually say no quadrant, because it's no quadrant, or you'd actually say x-axis. So that's kind of it. That's how you would label those. Again, not gonna be a test, it's a freebie, not even charging for it. Okay. Okay, but we are going to be graphing straight lines quite a bit here. So let's get used to it. And of course, I'm going to give you the one with the fraction here, because you guys are sophisticated Math 63 students. So what does a line that goes to the origin look like, or an equation of it? It looks like this: is y equals mx. And we'll talk about the m, and I know you already know about the m from Math 63 or from your high school classes here. But a few things we should know. First of all, if you don't know how to graph anything at all, you can always make a little table. Whether it's a straight line, whether it's a curve, an exponential line, whatever, it doesn't matter. You can always make a little table, and then you can always plug in values. What's the easiest value to plug in? Absolutely. 0 is the easiest, usually, almost always. So if I plug in a 0 into that, half of 0 is Thank you. You guys almost scared me here. Okay, cool. As my father used to say, you know, I used to mow the lawn every single Saturday, and he used to pay me $0, right? I get to stay in the home. And then, you know, on the following Saturday, he says, you know, I'm gonna double your wages. Okay, no, it's two times 0 is still 0. That's not cool. All right. 1 you can plug in. 1 times a half is going to be a half. And then notice the one little thing here. We're going to see this next time here on a few other problems here. If I have a half over here, if I multiply by 2, what's going to happen to the 2 and the 1/2? Yeah, it's going to become just a regular whole number, right? So whenever we're going to plug in, whenever we're going to have to plug in stuff, maybe it's easier to plug in a multiple of that denominator right there. Good, good. I'm going to ask a few people to quiet down, please, and if you can't, then move. All right? Okay. So 0, 0. 1 comma half. Looks like about right here, right? 1 to the right and about halfway up to 1. And then 2, 1. The previous book that we used, it made you do 5 points first. That's not cool. That's a lot of points. But they wanted you to realize that whenever you draw a straight line, all those points have to line up. If you guys remember from high school geometry, they called it collinear. Kind of weird stuff like that. Okay, so you just want to make sure that all these points line up, but real quickly here, how many points really do we need in order to determine a straight line?
2.
We just need 2, right? As long as we had 2 of these points, like this one and this one, the third one is really sort of an extra point. So if you know that you plugged in 2 points correctly, you're good to go. All right, another thing. This little value right here, 1/2, I know you know this from Math 61. This one tells you the steepness of the graph. Real quick. If it's positive, you know it's sort of going up a little bit, right? We'll take a look at that more in 3.3. If this number is a negative number, that means we're technically going down the hill. Are we good? But this little number all the way at the end, notice this little 2 here. This one tells you where it's going to cross through this little y-axis. And so if it's a +2, you know it's going to be a little bit higher. And then this y equals -1/3. Notice it goes right through the origin. If it's a -1/3 minus 4, guess what? It's going to be lower, is that right? Lower. So this little back number at the end is going to tell us sort of how high it's crossing this little y-axis. We'll talk a little bit more about that later. Okay. So let's jump to this here. And we're going to just sort of verify. Again, let's just get 2 points. Why do 3 points if we don't have to? And the easiest point to plug in is a 0. And this is the way your homework is going to be done. And if you know how to graph this by y equals mx plus b, you really don't need to plug in the 0. We good? You're like, oh, Mr. H, I know this. Go for it. Cool. But we're just sort of backtracking real quickly here. Okay, making a little table here. I'm going to make it a little different here. I'm going to plug in a 0. And what should we get? Of course we get a 3, because 0 times 1/2 is still 3. Plus 3 is still 3. Cool. All right, the reason why we know it crosses the y-axis is because whenever you plug in a 0, you're always going to get this number at the end. Cool? All right, and then we just talked about it here. What's the next easiest number to plug in if you have a 1/2? Not a 1, 2. Absolutely, because 2 times a half is going to get rid of that fraction for us, and then we can do the rest. Okay, half of 2 is 1. 1 plus 3 is a 4, and we got ourselves 0. Just kidding, not 0. It's going to be 2 comma 4. My fault there. All right, can you graph that? Should have been 2 comma 4. I'll fix it in just a second now. Cool. 2 comma 4, and to graph it, how about 0, 3 right here as the first point, 2, 4 as the next point, and then you can actually put more points into here, right? As you know, the different distance here, right? Looks like it goes 2 across as every time you go 1 up. You can actually put more points if you like, just to get it a little more clear line. Don't have to yet. See, that's too high. Then you gotta sometimes erase stuff just to get it just right. Okay, good there. Try to get it as straight as you can. Alright, next one. All yours from beginning to end. Go for it. Just for practice real quickly here. And again, if you know y equals mx plus b, get it that way too if you like. We'll cover that in 3.4, I think. So plug in a 0 minus 4 gets you a negative 4. And again, plugging in a 2 in this case. 2 negative 3, those should probably be your 2 points there. Alright, and hopefully you have a graph that looks like this: 0, negative 4, and then 2, negative 3, and a graph that looks like that. Again, a straight line that looks like that. Alright, but let's get a little bit more sophisticated here. You guys are sophisticated Math 63 students here. We could have also graphed, let me go back real quickly here to the one that we did previously, this one here. Right, with the minus 4 at the end, we could have just taken each one of these points down 4 units, right, each time. And so notice if I went 1, 2, 3, 4, there's that 2, negative 3 that I was graphing earlier. Okay, so just so we know that, we're going to use that sort of idea in just a bit here. But before that, let's go backwards. Let's see, can we, instead of finding the graph, can we go from a graph back to an equation? And yeah, we have an equation of a line that looks like this. That's sort of the general form, right? Y equals mx plus k. That k tells you sort of the movement up and down. And so what we learned so far is that that little k value, that's that little 3 right here. It's where it crosses the y-axis. So in that case, let's just write it over like this then. It's mx plus 3. Alright, the only other thing we know is we need to figure out what this m is. And we got 3 different problems here. We got a problem of 3 different variables. I got a y, a m, and an x. In order for me to solve for m, I need to know what y and x are at the same time. So here we go. Pick whatever point you like along this line. It doesn't matter which one it is. We're going to pick a point. There's a first point that we picked. I'm going to pick this point up here. Again, doesn't matter. As long as I label this point, I think that's going to be 1, 5. Is that right? So let's plug in 1, 5 into this equation. So the y value is 5. The x value is a 1. Hey, don't I have a single equation and a single variable to solve for? That'll work. M times 1 is m. If I subtract 3 from both sides, gets me m is equal to 2, and now I have or at least I know the other little constant in my equation here. Final answer, y is equal to 2m plus 3, and that is the equation of that line. Alright, and even if you're even more sophisticated than that, if you just knew 3 there and then you calculated the slope, you're even cooler than I thought. Okay. Okay, but let's get a little more complicated than that. Tell me if I need to go slower, okay? Tell me if I need to go back. Go ahead, Laura.
You said to get that.
Alright, how about this? What happens if I put a little x squared on that x? Once I do that, it no longer becomes a linear equation. And again, if we don't know how to graph this here, we're going to have to make a little table. And depending on how many points we need in order to fill in the graph correctly here. Alright, and then usually if it gets a little more complicated, we usually make it into this kind of a chart here. Because then you can see what you plugged in, you can see what you calculated, and you can see what you got out. If you can sort of do all the calculation in your head, then you can just put x and y coordinate there. Cool. Alright, let's go for it here. The easiest one to plug in is 0. No work to show whatsoever. I love it. Just gives me a 0 at the other side, because 0 squared is still 0. As my father said, double my wages, still get a 0. Okay, free room and board. That was kind of good. Free food, that was good too. So, okay, so let's go for it here. Plug in a 1. Let's see, let's plug in a 1. 1 squared is a 1. Times 2, just give me a 2. I'm going to put in some other ones here just because I know what the graph's going to look like here. Plug in -1. Let's see, how about plug in a +2 and a -2? I'll let you guys do that. And again, the reason why we're plugging in a whole bunch of points is because this is nonlinear. We've got to see where sort of the curve is going to be. So plug in -1. -1 squared is still a +1. Okay. Yeah, times 2 is still 2. If I plug in a +2, alright, this is, let's see, 2 squared is 4. 4 times 2. Whoa, we're at 8 already. This is actually even off the chart. But it's just slightly off the chart. So that's still okay. I can probably still graph it. I'm going to just sort of graph it above my graph. Alright, -2 plugged in. And what'd you guys get for -2? Still an 8, okay. So let's plug this in. So 0, 0 is my coordinate. 1, 2. -1, 2. Alright, 2, 8. Looks like this is 5. This has to be 6. So I'm going to sort of eyeball it a little bit. That would be 7 about here somewhere. That means 8 is about here. So that means 2, 8 is generally about right there somewhere. Cool. Other side, same thing. Okay, and these guys, again from high school, if you guys remember, these guys sometimes called parabolas. They have a little curve next to them. And they go like this. Okay, the only thing is we should not do, don't make a V shape out of it. Maybe like a very scrunched U shape. There should be like a little curve right here, as opposed to a point. So we should be curving that little out a little bit. Cool. And again, parabolas, remember going back all the way to the first time we had a lecture at 1.4, anything that sort of curves, you could pretty much model it by a parabola of some sorts, or a polynomial of some sorts. So anything we have a volume of something, if you have a square of something, surface area of a soup can, anything, we try to at first model it like this with parabolas here. So very important function used in mathematics, but here's what we want to know. We want to know this sort of this whole concept of moving up and down. So this is in your textbook here. If k is a positive number, then x squared, which is we just did, 2x squared is what we did. If you add k, it's just going to move this whole entire graph up 2 units, or k units, sorry. If it's a minus k, that just means it's going to move the whole entire graph down so many units. So again, just getting a little bit more sophisticated here. Alright, and yes, you could put a little 2 in front of x squared if you like. You put a 4, put any number you like in front of x squared. For the previous problem that we had a little 2, right? It was 2x squared. So let's go back to that problem. This problem here, especially those little points here, 0, 0, 1, 2, 2, 8, negative 1, 2, and negative 2, 8. What I'm going to do, I'm going to jump to this. I'm going to put those points in already. Good there? That's from the previous graph, because I know what 2x squared is. Good there so far? What I want to do is I want to make a 2x squared minus 4 out of it. So what am I going to do to each of those individual green dots? I'm going to move them 4 units down each time. So 1, 2, 3, 4. Good there. Take this one. 1, 2, 3, 4. Good there. Because that's really what it means to move down. So 1, 2, 3, 4. That's now at negative 1, negative 2. Bring this one down. 1, 2, 3, 4. 1, 2, 3, 4. And the purple dots is really the dots now for my graph. Good there? So we're gonna, this is the basic formula. We have something called translation. We sort of move things around. If we get to chapter 10, which we just might, we'll be doing that with a whole bunch of different different graphs here. Okay, but just sort of understanding the movement of things. Alright, and again, graphing it, connecting all the points, making sure it's not a V shape, but more like a U shape, curving that bottom there. Alright, and something else students do sometimes, they don't put arrows at the end. If you don't put arrows at the end, what it just means it stops right there. So if you have been not putting arrows for the previous 6 graphs, now's your time to do so. Okay, so next one, a little bit different. Just getting you guys used to this concept of movement here. So the question for number 9 is, can you graph for me an absolute value of x? And based upon the absolute value of x, can you graph for me this one here? Because we can do this in our heads, right? Like, what's the absolute value of 0? 0. Absolute value of 1? 1. Absolute value of 2? And so on, right? Okay, what's the absolute value of negative 1? 1. Absolute value of negative 2? Yep, and then so on and so forth, right? Hey, that's kind of weird. Look, absolute value is a little V shape. That's where we get our V shape from. Okay, if I connect these, there's my y equals absolute value of x. You guys can graph that one. And then, can you graph for me without just kind of moving dots around, not making a table, can you graph for me y is equal to absolute value of x plus 2. Alright, and hopefully you're not waiting for me. Hopefully you graphed it. So, remember the little plus 2 at the end? It all just means that each one of these points will have to move up 2 units. Because this, if it was a minus 2, then we would move each of these points down 2 units. Cool? So the plus 2 means that little red point right here at the 0, 0 now becomes that little blue point 0, 2. The 1, 1 now becomes 1, 3. Again, 2, 2 becomes 2, 4. And really, I don't need that many points, right? Because once I get a few points, I know what the graph of it looks like. And again, so notice that the red graph and the blue graph are really 2 units apart each time as we graph. Good there. Again, getting you guys used to the concept of translation just a little bit. Cool. All right, now let's finally get to what we want to get to here. This is one of the ways we graph. This is called the intercept method. And these straight lines, usually, not always, but usually, they will cross at 2 points. One is going to be along the y-axis, and the other point is going to be along the x-axis. Why is it useful? Is because what's the easiest number to plug in again? 0. So we can figure out, if I plug in a 0 in for the x, figure out the y-intercept, plug a 0 in for the y, get the x-intercept, we got ourselves 2 points really quick, and we're done. So this is one of the ways we can graph very quickly. Some of you guys hopefully can do that in your head. If you can graph it in your head, you're doing great. Okay. And I guess the only other thing to mention here maybe is this little point 0,2. If I were to sort of put a point here, this would be 0,3, is that right? This would be 0,4, 0,5, 0,6. Notice what happens. All these guys have in common x equals 0. Cool. Along this way, this is 1, 0, this is 2, 0, this is 3, 0, 4, 0. So along the x-axis, what they have in common is a y value of 0, which kind of makes sense, right? The y value of 0 would produce it. You're not going up, you're not going down, you're actually still flat along the x-axis. Cool? So let's go for it. Hopefully you guys remember. Find the x and the y-intercept of 2x minus 3y equals 6. Graph the solution set. Alright, the long way, then we'll do the shortcut in a little bit here. So to get the x-intercept, we're going to plug in a 0 in for the y value. Alright, so 2x minus 3 times 0 is equal to 6, and of course anything times 0 is going to be 0. So this whole thing can actually go away. Really what we're doing is we're solving 2x equals 6. And that's going to be x equals 3, obviously. Going the other way here for the y-intercept, we're going to plug in x for the 0 this time, or x as a 0, so 2 times 0 minus 3y equals 6. Really, technically, again, do we even need to write this down? No, because this is going to go away, right? So how about negative 3y equals 6 right away? At that point, you should be able to figure out that y is equal to negative 2. In any case, here's the 2 points that I really want to graph. I want to graph 3, 0, because remember, I get an x-intercept if y is 0. If x is already 0, then I get a y-intercept of negative 2. So plug in both of these points in, 3, 0, 0, negative 2, straight line, and good to go. I'll wait for you guys to catch up. Alright, for the sophisticated of you guys here, what's the quick way we usually do it? We usually go like this. We just make a quick table. Because you can probably do this in your head. So if you plug in a 0 in for the x right over here, you know it's going to be negative 3y equals 2, and you can pretty much tell that the y value is going to be negative 2. Plug a 0 in for the y value here, this disappears, and you know that x has to be 3. Look at, that's kind of the shortcut, fast way that students do that, which I'm sure most of you guys did that already as well.
You always put in red.
Yes, and the reason for it, it's the easiest one to plug in. Yes. Which one? Yeah. Alright, and if you did this any other way, you should get the same exact graph. Right? If you solved it for y, not to say anything or anything. Okay, there is a time where the x-intercept does not work. And let's take a look at that one maybe before we go on, because it doesn't show that on the slides here. So let me do this real quickly here. Let me add an extra little page into here, extra little graph. Let's see, what should we do? Can't call it 11 because we already have a next one that's called 11. So how about we call this like 10 and a half? Will that work? Kind of makes sense with math, right? Okay, how about this? I'm going to change this guy into, how about 2x minus y equals 0. There it goes. Only time this little process of intercepts does not work is when you have this little 0 all the way at the end. So if it's set equal to 0, we got ourselves a problem. Because when I make up the little table, bless you, I plug in, let's see, I plug in a 0 in for the x, right here. 0 times 2 minus y. That disappears. And what's the y value going to be? Okay, 0. So that means if I plug in a 0 in for the y, guess what I'm going to have for the x? 0. So instead of having two different points to draw my line, I have just one individual point right here. And that's my problem. Okay, in this case, we're going to go back to what we just learned, or with the first problem that we did. We just need one more number in here. It doesn't matter what it is, just plug in something. I'm going to plug in a 1. So 2 times 1 minus y equals 0, and solve that for y. Again, we've got to do that because intercept method is not working. It only gave us one single point instead of two different points. 2 times 1 is 2. Subtract 2 from both sides. Totally cool stuff. Divide through by -1. Multiply through by -1. Doesn't matter. Eventually, everybody okay with the 2 for the y? So there's that. Got it. Now I got my 2 points. So 1, 2 is right here. And now I get to finish off the problem. Okay, good there? There's the time that it will not work. Hopefully your graph is more straight than mine. A little bit off. Okay, since I think we got it now, let me throw you an interesting one here. Y is equal to x squared minus 1. Alright, let's see how we're going to do this here. This one's a little more complicated, so maybe we go to the first way here. Let's go like this. X-intercept, can't really do just x and y table here. I'll give you a hint, since we covered factoring in chapter 1, we might be factoring. So let's see, in order to get the x-intercept, we got to plug in a 0 in for the y value, and if I do that, I get myself look something like this. Anybody remember anything like that from 1.4 or from the test that we just took? Yeah, this thing is a difference of 2 squares. So that will factor down into x plus 1, x minus 1. Alright, and then let's see, set each of them equal to 0. Solve, and I get myself x equals -1, x equals +1. Ooh, it's kind of different here. Alright, let's see. If I plug a 0 in for the y, I actually get 2 x values out. So that means I'm going to have 2 x-intercept. One is at -1, 0. The other one's at a +1, 0. Alright, going on the other one here, y-intercept, Plug a 0 in for the x. That was a little easier. And let's see, 0 goes in for the x. That's a lot easier here because 0 squared is 0. 0 subtract 1 is a negative 1. In this case, just one single y-intercept. And notice it doesn't say to graph. It just says find the intercepts. So at that point, you're done. As far as homework is concerned, you can just kind of do this here, put a little comma right here, and you've just got all the intercepts. Alright, this is one way to write it. There's also another way to write it. So you can write it by coordinates. You can also write it like this. You could say x intercepts equal negative 1, 1. That is just fine. And then what you do over here, you just say y intercepts equal, or intercept equals negative 1. Good there? You just list them individually or just list them as coordinates. But don't mix the two up because then it kind of looks weird. Okay, just real quick here, what does a graph looks like? Again, this is going beyond the homework, but it just means this here at negative 1, 0 right here. This is where this point crosses the x-axis. Positive 1, 0 where it crosses the x-axis. At 0, negative 1 right here, it crosses the x-axis. Hey, isn't that a parabola? Look at that. Cool, cool. Even more so, real quick here, isn't this x squared moved down 1 unit, right? So it would have been like this, except now it's moved down 1 unit each time. Here and here and here. Math makes sense. This is kind of weird. Okay, quick recap here for 3.1. So some facts from geometry. So we looked at this line right here, a line that goes through the origin. Y is equal to mx, goes through 0, 0. Then we have some weird lines here. We have something called a vertical line. It's a special straight line. This one goes up and down. And the equation for it looks like this. It's just x is equal to a. Alright, then we have the horizontal line. Going to use these quite a bit here. And that equation is y equals b. And so whenever you see x is equal to some kind of number and you are graphing inside an x and y grid, we just figure out where the a value is, what that value is, and go straight up and down. Y equals b. We figure out where we at along the y-intercept and go straight across. Again, very rudimentary stuff, but I'll let you guys graph. Last problem here of the section. Can you graph for me x is equal to negative 1, and then can you also graph for me y is equal to 4? I think we have to do it on the same graph paper, I think.